So in example 1, each sequence is explicitly defined. In other words, it's giving us a formula where we can go directly to the nth term. We want to write the first 3 terms and then skip to the 30th term of each sequence. So for example A, in order to find the first term, we plug in 1 everywhere there's an n. It's a plug and chug. So our first term is a -1/2. Our second term, we plug in a 2 for n, and we get a positive 1/4. Plug in a 3 for n, we get a -1/8. Before we jump to 30, I want you to notice that our sequence here alternates signs. It goes from -1/2 to a positive 1/4 to a -1/8. This -1 to the power of n is one way of getting that oscillating sign, those alternating signs. If you want it negative, you can do -1 to the n. If you start with a negative, if you want to start with a positive, you could do -1 to the n-1 or n+1. Now let's skip down to the 30th term. -1 to the 30th divided by 2 to the 30th. Well, again, -1 to an even exponent is going to give us a +1. And 2 to the 30th is pretty large. Normally, I would just have you leave it as 2 to the 30th power. But if you were to multiply it out, I've already written it out here. It is 1,741,820 But again, I'm fine if you have an exponent that large to just go ahead and leave it as 2 to the 30th. Part B is a little bit different because it's given to us as a piecewise function, but that's fine. Our instructions is if it's an odd term, then we use that top portion. If it's an even term, we use the bottom portion. B sub 1, our first term is odd, so we're going to use that top formula. We will have 1 minus 1 factorial divided by 3. Remember, 0 factorial is defined as 1, so we get a 1/3. And if you forget, you can put 0 factorial in your calculator. It will give you a 1. B sub 2, our second term, so it's even. So we're going to use that second piece, 2 times 2 cubed. Please, please, please do not forget your order of operations. We have to cube the 2 before we multiply by the 2. So 2 cubed is 8, and that gives us a 16. B sub 3 is an odd term, so we're going to use the top one. This time plugging in 3, so 3 minus 1 quantity factorial divided by 3. We get 2 factorial divided by 3. 2 times 1 is 2. So we get a 2/3. We can also jump down to the 30th term. And again, 30 is even, so we use the bottom. 2 times 30 cubed. So that's going to give us 2 times 27,000, which equals 54,000. Our last example gives us a recursively defined formula, which again means that we have to know the term before it. And we want to write the first 3 terms of the sequence. Notice that they had to give us the first term in order to start. So even though it said the first 3, let's go ahead and do the first 4 so we can get the practice, because A sub 1 is given to us. So we know A sub 1 is 1. To find A sub 2, we would have 3 times. So notice you could plug in that 2 for your n plus 2, which means 3 times A sub 1 plus 2. A sub 1 is 1. So we get 3 times 1 plus 2. We get 3 times 3, which gives us 9. So again, this n minus 1 just means the term before it. So A sub 3, the third term, would be 3 times A sub 3 minus 1 plus 2, which equals 3 times a sub 2. So again, we're looking for a sub 3, so we got to use a sub 2 plus 2, which gives us 3 times, this time 9 plus 2. 3 times 11, which is 33. So notice how we knew a sub 1, so we used a sub 1. We knew a sub 2 was 9. Here we plugged in 9. So we're using that previous value. Just one more for good measure. 3 times a sub 4 minus 1 plus 2 means we're looking at 3 times a sub 3 plus 2, the previous term. Our previous term was 33, so we plug in 33 plus 2. We get 3 times 35, which gives us 105. So that's the difference between the recursive formula, where you have to know the term before it, or possibly 2 terms before it if it puts n minus 2. Okay, but again, they have to give you enough terms in order to satisfy the definition in that formula. All right, that's an introduction. I hope you enjoy. If you have any questions, please stop by and see me. Thanks. Bye.